Alright, so it's been a while since I posted a video. It's been a couple of months, and that's been because I've been very busy working on a project. You've already seen the video thumbnail, but basically the project that I set myself at the start of this year was to make myself one of these. A lot of you probably already know what this is, but this is basically the DJI motion controller. Now, DJI, they're a bit of a controversial company. The way they run their business and the way they treat their customers isn't great. But on the flip side of that, they do make extremely good drone gear. They are literally the market leaders with drone gear. They make very, very cool stuff. And one of the things they make is the motion controller. Now, for those of you that don't know, the motion controller is basically it's a handheld device that you use to control a drone. Obviously, normally when you're flying a drone, you would use something like this, just a radio with two sets of gimbals and various switches, and obviously you control the drone by moving the gimbal sticks here. But the motion controller works differently. That works by literally moving your hand around, up, down, left, right. The physical motion of your hand is translated into a command that's sent to the drone. It works very similar to like a Nintendo Wii controller, something like that. Now, I've always thought that the motion controller is very cool. I've never actually tried one, but I've seen plenty of videos of people flying DJI drones with a motion controller, and I always thought that looked very cool. And then recently they had the anti-gravity A1 drone come out, and that came out with a very similar sort of controller. And I kind of hoped that, I don't know, like Radio Master would bring out something like a motion controller. I've always thought that looked like a very intuitive way to fly a drone. So I was kind of waiting for someone to bring one out, but it never happened. So at the start of the year, I set myself the project to make my own. I'm about sort of 2.5 months into this project. I've made a lot of progress and I'm feeling very happy with it. The project is nowhere near finished, but I figured that in this video, I'd just show you what it is I've been working on and how far I've got. And then I'll talk to you a little bit about what it is that I'm sort of planning to do moving forwards. So I think the first thing to do is to show you, where I'm at so far. Now I know you've already seen the video thumbnail, but this is how far I've got. This is the motion controller that I've made. As you can see, handheld device with a trigger on it. That sort of size and shape. Now I just want to stress at this point, I have put very little thought into the ergonomics and the aesthetics of this device. So it doesn't look great, I'm aware of that. At the moment, I've very much prioritized function over form. So functionally this works, but I will be doing a lot of work in the future to just make this look nicer and also just feel a little bit nicer in the hand because it is a little bit clunky. But yeah, this is what I've come up with so far. Obviously this is a 3D printed housing. And there's not really a lot to say about it at first. I mean, so you've got a trigger here. Obviously you hold it, like this, trigger there. You notice it's like a 2-pronged trigger. That is because obviously you need to be able to, pull it back to throttle up, but also you need the ability to throttle down. I could have obviously gone for a spring-loaded trigger, but I've designed this to be used with fixed-wing drones as well as multi-rotors. And obviously if you're flying a fixed-wing drone, you could be in the air for a very long time whilst flying that, half hour, even longer, and you don't want to have to sort of continuously hold your finger on a trigger fighting against a spring. So it's just easier to just have this this trigger here that you can push backwards and forwards. Again, no thought has been put into the aesthetics. I will at some point make this trigger look much nicer, but functionally it works. You can push it back and forwards. On the top of the device, we've then got a couple of switches here. So there's an arm and disarm switch, and there's a return home switch. I will be adding a third switch for modes at some point. I just haven't got around to that. And actually at the moment, these switches, although they're wired in, they're not actually being used, which I'll explain a little bit. The only other thing to mention on it at the moment is there's a joystick. And this joystick serves 2 functions. So the main function, because of the way that accelerometers work and gyros, and that is a key component of this, because of the way that they work, they can detect like a change in gravity. So that works great for pitch and roll, but it doesn't work for yaw. Because when you're yawing an aircraft, and if you're doing a yaw motion with your wrist, there's no change in gravity. All you can detect is a change in acceleration, which means that for as long as I'm rotating the device, you get a yaw signal, but as soon as I stop, it doesn't. It's quite complicated to explain, but long story short, to do the yaw, we've got a little joystick which we can push left and right. So yaw is done, by moving your thumb left and right. That's the only control input which is done, by moving your fingers. Everything else is done through hand gestures. Now, like I said, this serves two purposes. So yes, it is doing yaw, but it is a clicky button, so I can push it in. Hopefully you can hear that. The function of that is to lock and unlock this device, which we'll talk about a little bit in a minute. So those are the main controls, and then there's just a little LED here. This is a status LED, which again we'll talk about in a bit. Now, just to make it clear where I've got to in the project at the moment, the long-term goal will be to make this a all-in-one device, which means that you use it, literally, this is all you need. You just take this device with you. But you will notice that there is a cable hanging at the bottom of this. That is because at the moment, there's no transmission module built into this. There's no actual radio hardware in this. So at the moment, the way this works is that you take this cable here and you plug it into the trainer port on a radio. You can see that. Plug it into the trainer port there. And then you use it, like a trainer. Now, again, just to stress, the long-term goal will be to put a radio module into this. I've already started doing the preliminary work on that. But at the moment, you do still need your standard radio. And the way it works is quite simple. Obviously, all you have to do is enable a switch. On my radio, it's this switch here. And when you flick that switch, it just hands over control from this radio to this one. At which point you can just put this radio down, and then you fly exclusively with this. Long-term goal will be to include all of that, but at the moment it's wired. Now there is also there needs to be a second wire as well, because at the moment this doesn't actually have a battery. Again, that's something that I will be adding. I'll be putting a battery in. So at the moment you need just a USB power bank, and then a cable which plugs into the bottom here into this USB port. And I'll sort of show you that quickly. You'll see the light lights up. Neat little tune. At the moment when you use this, it is a little bit clunky because you've got wires everywhere. Just trust again, the long-term goal will be to not only make this look a lot nicer, a lot more ergonomic, but it will be a all-in-one unit with a radio installed and hopefully a battery as well, so that you can use this just as a standalone device, like you would with just a normal radio. So that's going to be the long-term goal. But anyway, at the moment, let me just talk to you about how far I've actually got and how well this works. So if you think that you can just buy an accelerometer and a gyro and then just kind of connect that to like an Arduino and then just instantly make that work, you'd be very wrong. It actually took a ridiculous amount of coding to get this to work, and I don't know how to code, so I've had to rely on ChatGPT a lot. And also, if you think that you can just say, hey ChatGPT, write me some code, and then it just does it first time, again, absolutely not. It's taken months and months of many firmware revisions and tweaks to get things working. ChatGPT is a very good tool, but it's also very finicky. So it's taken a long time. And at the moment, I think there's something like 5,000 lines of code that have gone into this. A lot of that is things like filtering, because if you just take the raw signal out of an accelerometer, it's very noisy, very sensitive, very twitchy, and if you try to fly a drone using just a raw accelerometer signal, it would be impossible. So a lot of programming and a lot of time has been spent on putting in various filterings and sort of things like sort of deadband and expo and just like smart kind of control algorithms, and it's way more complicated than I'd care to explain in this video because we'll be here all day. But that's the majority of the work has been done, is on the code side of things, to get this actually to work the way you want. Now, let me just talk to you a little bit about how the device actually works. So I'll have to put a little bit of footage up here so you can see what I'm talking about. But obviously the first thing you're going to do is, when you want to use this, you need to power it up. So I'll plug the cable in to the device now. And as I power it up, you're going to hear a little tune play. That's just a little power up tune. And then after about 5 seconds, you should hear another little tune. So let's just do that now. There you go. That second little tune that you heard there, along with the LED flashing, that's basically letting you know that the device has warmed up. Now, obviously, if you've been flying, Betaflight or iNav drones or autopilot drones, you'll know that when you first power up your drone, you have to then just not touch it for a few seconds. It needs to just be sat there completely idle. That's because the IMU needs time to warm up, and it needs to be completely stationary to do that. And the motion controller, because it's essentially got the same hardware as what you'd get on a flight controller, it needs the same thing. So when you first power up this device, you have to then just leave it alone for a minimum of 5 seconds. It needs to be completely still for 5 seconds. And then, if those 5 seconds pass without any motion, you'll get that happy little tune. It lets you know the device has booted up properly and it's ready to go. Now, if you were to boot this device up and not leave it still for 5 seconds, after 60 seconds, if it hasn't managed to pass that safety check, you'll then hear a very unhappy tone, and I'll let you hear that now. And that unhappy tone that you just heard there, that is the device letting you know that the IMU has failed to safely warm up, at which point the device has locked itself and you cannot unlock it, you cannot use it, you have to then power cycle it and try again. That's a very important safety feature because of the way that IMUs work. If you don't let this device warm up properly, it won't work properly when you try and fly it, and you're almost certainly going to end up crashing your drone. So when you first power this up, the safety feature, 5 seconds, just to let the IMU warm up. That's one of the the first things that I had to set up to get this working. Now, let's talk about when you actually want to use the device. So contrary to what you might expect, you don't actually hold the device upright like this. Instead, you actually hold it like that. Originally, when I started working on this, I did have it in mind to do this, but I actually realized that ergonomically, or like comfort-wise, that I didn't feel very natural. It feels way more natural to hold the device like that. So in a sort of side-on configuration. And the way that this is programmed is that, by default, once it's all powered up and everything, it's still not actually sending a live signal out at the moment. And that is because the device needs to be unlocked. And the way to unlock it is to press this button here. However, there is a second safety feature in place now. And that is that the device will not unlock unless it's in the correct orientation. So at the moment, if I try and unlock it, you should be able to hear this. Hopefully you can hear it's playing a little like unhappy tone, and it's saying denied. I'm refusing to unlock. I'm not going to do it. That is because it is detected that it's not in the correct orientation. The reason why I've programmed that in is because the last thing you want is that you go to fly your drone and you unlock it in the wrong orientation, and then instantly it's going to send some crazy signal to the drone telling it to shoot up into the air or go left, right, whatever it is. So basically, you need to have the controller in the perfectly sort of level orientation. So basically, the equivalent of having the sticks on your radio centered. You need the device to be in a perfectly level orientation, and only then will it unlock. And hopefully, you'll now hear it. You hear that? So there's a different tone there. So this is the unlock tone. The device is now unlocked, and then press it again. That is the device locked. It's very important that we have this ability to lock and unlock the controller, and we'll explain more about that later on. But yeah, basically, when it's unlocked, at this point the controller is now sending a live signal. So as I move this, if this was connected to a drone, it would actually be making the drone actually move around and actually be able to control it and fly it. So that's a very important feature that I've got on this device. The ability to lock and unlock it, and the fact that you can only unlock it when it's in the correct orientation. Now, before I sort of show you anything else, I need to explain that you might be wondering, how is it that you might want to sort of make programming changes on this, or tweak any of the settings. So the thing I now need to explain is that this device actually has Wi-Fi built in. Now, by default, Wi-Fi is disabled, and that is because when you've got the Wi-Fi running, it actually messes up the PPM signals coming out of this. They get very jittery, so you don't want to fly with Wi-Fi enabled. But if you want to change any settings on the device, you enable Wi-Fi, and then this device is actually generating its own like web page, and then on any browser. So like probably on your phone, but I'll show you on my computer in a moment. On any browser, you connect to the Wi-Fi coming from this device, and then you can access the website, and that will allow you to then make changes to the device. So I'm going to show you that now, and the first thing I'm going to do is I'm going to show you how it is that you actually enable Wi-Fi, and it's all to do with the boot sequence. So if I disconnect the power from the device, disconnect it, and now if I put my finger on the joystick and I pull it up to the left, hold it, and then power on the device, you're going to hear the boot up tone, but it's going to be different. And then you're going to see the LED is actually, rather than being on and static, it's going to start flashing. So I'll show you that now. So there's the different boot tone. And then yeah, you'll see that the LED is now flashing. And there's the little tone just to let you know the IMU's warmed up. So yeah, so the device is now in Wi-Fi mode. And like I said, the LED's flashing. That's just to let you know this isn't normal mode, this is Wi-Fi mode. And then we can now access the hotspot that's coming out of the device. Like I said, you probably do this on your phone, but I'm going to show you on my computer. So let me just get that loaded up now. Okay, so what you're now seeing on the screen here is the web page that's being generated by the motion controller. And like I said, you should be able to access this from any internet connected device. Now, the point of this interface is mostly to allow you to make changes, but it's also going to be quite useful in a moment because it's going to allow me to explain how some of the features on this device works. But as you can see, you've got a little interface here. At the top here, you've just got MC Tuner and then some status information about firmware and the storage on the device. So that's not really important. But then underneath that, we've got this section here for profiles. At the moment, you've got the ability to have 3 different profiles. And the reason for that is because you might want slightly different settings for different drones. So you can configure settings specific to each one. So yeah, you've got this option for profiles. And then underneath here, we've got the status monitor, which we'll talk about in a moment. And then underneath that is just a whole load of different settings here that you can tweak. To make various different things on the motion controller work in sort of various different ways. Like to give you an example, this section here about the roll, this allows you to change like the dead zone for roll, the expo for roll, things like that. And you've got the same thing for pitch down here. So you can fully tweak a lot of the settings here, and like down in this section here, you've got the option to reverse channels, change the channel map. This section here allows you to change what the switches do, although like I said, I haven't got them enabled. You've got a section here for calibrating the throttle, a section here for calibrating the joystick for the yaw. And then this stuff here with the red sliders, this is stuff to do with the safety features on the device, which we'll talk about in a moment. So yeah, you will be able to fully configure just about every setting on this device, to fine tune it to how you'd like. Much the same as you would be able to do with any sort of like proper radio. But what I want to now talk to you about is this this status monitor section here, because it will allow me to explain in detail how it is this device actually works. So what we've got on the screen at the moment, you see this green box here, but you'll notice it's actually divided into 4 separate regions. So this first region in the middle, this represents the dead zone area. So this basically means when you pick up the controller in your hand, you're never going to be able to hold it completely still and level, and you want the controller to kind of ignore the fact that human hands just inherently shake a little bit, like we're never perfectly static. You don't want it to send any signal to the drone in response to just natural small hand movements. So there is a dead zone area in place, and that is configured in the settings here. You've got a section here for dead zone roll and another one for dead zone pitch. And by moving the sliders down here, you'll see that moving these sliders will actually change the actual size of the dead zone region in this box here. And that's a good thing about this graphic, is it allows you to visualize what it is you've changed. So anyway, yeah, in the middle, this box here, that is the dead zone region. The box around that, that's then the sort of the command region. So I should explain that on the graphic, the little white dot, if I unlock the device, you'll see that the white dot, as I move the controller around, the dot moves. When you're actively sort of flying the drone and controlling it, the dot should always be in this second box here. This is just like the standard like sort of command zone region, and this responds to a certain amount of tilt, which is determined here by roll max in degrees and pitch max in degrees just there. So at the moment, roll max is 40 degrees and pitch is 35. So basically, when I'm sort of flying, you can move the controller sort of 40 degrees left or 40 degrees to the right. That will correspond to 100% left roll or 100% right roll. And then, you can pitch the controller up 35 degrees or down 35 degrees, and that will correspond to, 100% pitch up or 100% pitch down. Hopefully that makes sense. So yeah, as you're moving the controller around, the dot should always stay basically in that second box, which corresponds to those angles. Now the third box, that's basically a little buffer zone, and I'll show you now. If I unlock the device, if I allow the dot to leave the command zone and go into buffer zone, you should hear a single beep. There you go, did you hear that? That little single beep there, I'll just do it again. That single beep there is just letting you know that you've reached the edge of the command zone and that you're tilting the controller too far. Now this is a preliminary warning, because if you continue to tilt the controller too far, the dot, as you see on the graphics, will then enter the last box there, the one with the hash markings on. And that is known as what I've called the UCF zone, or the unintended command filter. A great little acronym there. But basically, if the dot enters that zone, or put it another way, if you tilt the controller too far past, what you should be doing with it, that will then trigger a kind of failsafe. Now, I'll demonstrate for you now, and then I'll explain to you what's happening. If I unlock the device, and then if you look at the graphic, if I keep moving the controller, at the moment it's in the command zone, then keep moving it and you'll hear it beep. I'm now in the buffer zone. If I keep moving it and it goes into the UCF zone, you see the dot turned red. This is now emitting an alarm, and the only way to get this alarm to stop will be to put the controller back to level, like that. And you'll notice that as I move the controller, that alarm, the pitch changed. The reason why the pitch changed is that's there to try and help you to just orientate the device and make sure you get it to level. Obviously, I'm thinking that when you're flying, obviously if you're wearing goggles, you can't look at the device to know where it is. So it's just a little thing just to kind of help you orientate it. If I just trigger that again, so you can kind of hear, the closer I get to center, the more that the tone changes, and the lower it gets until I get back to level. The device doesn't need to be perfectly level, it just needs to be almost back to level. Now, you might be wondering, why have I got this feature in place? Well, obviously, if I'm just flying and, I don't know, it's a bit of an extreme, but say that I forget what I'm doing, and then I go to scratch my nose. The last thing I want the device to do is to suddenly send, at this point, the controller is very upright. That's going to tell my drone to just instantly climb really high. If it's a fixed wing drone, that's going to put it into a loop-the-loop or something. You're going to end up crashing your drone. So that is set up so that if you do any kind of movement with this controller that, isn't probably like a normal command, up, down, left, or right. If anything really extreme happens, like if I dropped the controller, for example, the device immediately is going to detect, like, that's a very unusual angle. It's going to trigger the alarm, and it does more than that. It doesn't just trigger the alarm. If we have another look at the graphic on the screen as I do this, so you see the sliders there for roll and pitch. As I move the device, roll and pitch move around. But if I put it into the UCF zone, watch what happens to those sliders. Hopefully you saw there that both of those sliders, they instantly returned back to 0. Basically, the thinking is that, say that you're flying and you drop the controller, or, you forget what you're doing, you scratch your nose. The controller is going to detect that is probably not an intentional command. Therefore, let's ignore what the controller is doing. As a safety feature, we'll then put all of the command inputs back to 0. That's the equivalent of, putting these sticks back to 0. And that should mean that the drone will then it'll ignore any commands from the controller at that point. And it will, put the signals all back to 0, which means that the drone, whatever it was doing in that moment, it should just self-level and go back to flying sort of like safely. And then the controller will not give you control back until you reorientate the device back into the level orientation, ready to then take back control. Now, I'm still tweaking this feature a little bit, but to me, it's a very, very sensible feature because, like I said, if you're flying and then you suddenly forget what you're doing and you go scratch your nose, it instantly detects that that probably wasn't an intentional command, and therefore the controller knows to ignore it. I think that's just a very important thing, because otherwise you could be flying and you could forget what you're doing and just do that. That's going to tell your drone to just suddenly go into a crazy climb, or if I let my wrist go limp and I drop it down, it's going to tell the drone to just fly into the ground. Obviously you don't want that. So you've got this quite complicated feature set up, which will allow you to, it will make sure that the drone doesn't do anything that's non-intentional. And that's why I called it the UCF, the unintended command filter, because the point is to try and filter out what is an intentional command. Like this would be intentional, up and down, or like roll left and right, that would be intentional. But me doing that, or just dropping on the floor wouldn't be intentional. So that's kind of a filter to try and determine, what it is that you actually want the device to do. Took a very long time to get that working. So hopefully that kind of explains how it is that this device works. So obviously, normal flight, just, pitch, up, down, roll, left and right. You're done with this, and then throttle done with this. You've got all of your, core features for flying a drone included in just this one device. Almost all of it's done just through, obviously, just motion control, and sort of feels very intuitive. But yeah, there is just, obviously these safety features there to try and help. I'm kind of rambling a bit, I apologize. So anyway, that's how far I've got with sort of building the device and doing all the programming. And obviously what you want to know is, does it work? Well, yes it does. It actually works really freaking well. So I've only managed to test this a couple of times. But I'll show you footage from the flight I did most recently, because that was the best one. That's the one where I had absolutely no issues at all. And it worked absolutely fantastic. Now, just to explain, obviously at the moment, because this has to be connected to my Radio Master Pocket, and I was flying a fixed wing, the way I did it was, I just armed the aircraft with this radio. I then, put the throttle to 100, through the aircraft, got it up into the air, flying using this radio. What I then did was I put the aircraft into return home, so it was loitering, it was flying itself. At that point, I then hit the trainer switch, this one here, which handed over control to this controller. I then unlocked the device. I then disengaged return to home. And at that point, I then had total control of the drone using just the motion controller. At this point, wasn't really using this radio. The only thing it's doing is obviously it's just transmitting the signal. But all of the flight controls was done using the motion controller. And yeah, that's what you're seeing in this footage here. And actually, it worked phenomenally well. I was actually really, really happy because it's taken so much work to get this controller to this point. But actually, it worked really well. It was actually kind of as I suspected. It felt like a really intuitive way to fly. I mean, I guess there's a reason why, in fighter jets, they have a joystick. They don't have like a big yoke and stuff like you get on a commercial airline. They have a joystick because it's so much more intuitive to fly just by sort of using your wrist motions than it is sort of using sort of sticks. So actually I don't know how else to say this. I just felt very sort of in tune with the aircraft as I was flying it. It just felt so much more intuitive, and I felt so much more fluid in my motions. It just worked really, really well. And I was even able to, do a little bit of acrobatics. I was able to, do a couple of rolls with the aircraft, nothing extreme, but just to prove it absolutely could be done. And I should explain that I did this flight in horizon mode, so it's a partially stabilized flight mode. And I think that is very, very important, that when you use the motion controller with a drone, it needs to have some degree of stabilization. Mostly because, when that UCF failsafe gets triggered and the commands all go back to zero, when that happens, you really want the aircraft to level itself out, because otherwise it will just keep doing whatever the last command was. In principle, you probably could fly this with like a drone in acro, I guess, but it's a bit more risky. But yeah, flying it in like horizon mode or angle mode or cruise mode, all of those modes would work extremely well. Those are kind of the modes that you want, something with some degree of stabilization. Now, during the flight, I did also deliberately test just to make sure that UCF worked perfectly. And what I did, as you see here, is I brought the controller to my chest. As that happened, initially, because the drone initially detected the controller moving up, the drone did sort of shoot off at a weird angle. But then as soon as UCF kicked in, obviously the commands went to zero, and then the drone obviously then just knows inherently to stabilize itself and go back to flying level. And that worked, as you see here, absolutely perfectly. So that means that, when you're flying with the motion controller, if you drop it or if you forget what you're doing, you go to scratch your nose, whatever it is, in theory, you shouldn't crash your drone. It should just, immediately level out and shouldn't have any issues. So yeah, I actually had a great time flying with this motion controller. It actually worked really well, and I even managed to do a landing using the motion controller. It's just completely smooth, perfect little landing there. It worked absolutely great. So yeah, I'm really happy with how well this is sort of coming on so far. Now, let's talk a little bit about sort of things in the future, what sort of we're working on next. So obviously I've already said the long-term goal will be to put a radio module into this so that you won't need to have this connected to another radio. And also, hopefully, if there's room, also get a battery in there as well, so it'd be a self-contained device. It would be nice to maybe have a little screen on the device, maybe for doing the programming. I'm not really sure whether that's going to be doable or not, but if not, doing things through the the web user interface, that works extremely well. So I may just, when it comes to setting up radio settings, I might actually do it through the web user interface. I haven't really decided. And another thing I want to mention as well. So obviously I've kind of designed this to be used with fixed-wing drones, because I'm mostly a fixed-wing pilot. You can still use it with multi-rotors, but mostly designed for fixed-wing drones. And one thing you may be wondering about is, well, how would you actually launch a drone when using a motion controller? Because if you think about it, if I'm holding this in my hand and I got to throw my plane up in the air, it's going to be very hard for me to hold that perfectly still as I do it. And obviously, if I don't hold it perfectly still, that's going to send weird commands to the plane, and you're almost certainly going to fail. You're going to mess up the launch. It's not going to work. So that's one of the reasons why the lock switch is there. So the way that I anticipate that you'd do it is you'd have launch mode enabled on your fixed wing drone. And then even when this device is locked, you can still, as long as the aircraft is armed, you can still use the throttle. So my thinking is that you would have your fixed wing aircraft with launch mode enabled. You would arm the device, set the throttle, throw the plane, get it up into the air, because that's what launch mode will do. It will take it up into the air. And once it's up in the air and stabilized, you can then unlock the device, and then you can take over control. And I've already thought about this to some degree, because at the moment, if I arm the device, hopefully you can hear that beeping tone there. That's reminding me, or reminding you, that the device is armed, but it's still locked. If I unlock the device, that alarm now stops. Does that make sense? The thinking there being that obviously if you were going to be using launch mode, throw your plane, get it up into the air, that's just to remind you that you don't actually have control yet until you've unlocked the device. So yeah, that's what I'm thinking sort of for the long run, is that you would use launch mode on your drone in conjunction with this device, and that should work absolutely great. So yeah, I could talk about this project for ages and ages, because there's so much like technical details to talk about and so many more features that I've put into this, but obviously I'm aware this video is already getting quite long. And yeah, I just wanted to let you guys know what it is that I have been working on for the last couple of months and why it is I've been so quiet. So that is a little update for you. I've been working on this motion controller. I'm about halfway there, so this video will be part one. and at some point in the future there'll be a part 2 where hopefully this will be working with its own built-in radio and built-in battery, and I'll be able to demo a little bit more flight footage for you, because at the moment I've only managed to fly sort of 2 or 3 times. So yeah, there's a little update for you. I hope you've enjoyed this video. If you have, as always, please do give it a like down below, just to make me feel better about the fact I spent so much time working on this. Just let me know that it's kind of appreciated. Yeah, if you've got any comments or anything, or if you're interested in this project, let me know. And yeah, I guess that's all I've got to say for the time being. So I will leave you there, and I'll catch you in the next one. Cheers, guys. Bye. Put it upright. There we go. Let's arm the drone. Just take a second. And there you go. Hopefully you can see the motor start spinning. Let's now throttle up. Get her up into the air. A bit higher than that. And then we'll try and center the throttle so she hovers. And then let's try roll to the right, forwards, roll to the left, roll to the right again. It's a yaw her, so use the joystick. Roll to the right, yaw her a little bit more. The yaw's a bit sensitive. Forwards. Backwards. Much more sensitive going backwards and forwards for some reason. To the right. To the left. Forwards. This is working great. To the right again. To the left. Forwards. Backwards. Just hover her. Try and hover her there. There's a little bit of oscillation in the hovering, but quite hard to get this device perfectly centered. You need to add some kind of feedback so it knows when the device is leveled. Forwards. Bring the throttle down a bit. To the right. To the left. To the right. Your left. Your right. Your is very sensitive. Bring her back. See if I can land her just in front of me. Throttle down. Disarm. And lock. Perfect.